Imagine you were at a family gathering. Someone brings up a story from years ago, and you vividly picture the room, the light, the color of the tablecloth, and the joke that made everyone laugh. But then a relative jumps in and corrects you. They insist the entire conversation happened outside, not inside. Your immediate reaction is to reject their version, but then they mention specific details you had forgotten. A strange psychological friction sets in. Almost immediately, your own version of the event begins to shift, accommodating their timeline until you can see the outdoor setting in your head. We trust our memories the way we trust a recording. We assume the brain simply hits save and files the experience away. But the biological reality is that the brain quietly edits past events each time you recall them. When you remember an event that never happened, it rarely originates from a lie or an intentional deception. It happens because of an invisible reconstruction process that fires up the moment you reach back to retrieve a detail. The sheer vividness of a memory offers no proof of its accuracy. To understand how a false event can feel flawless to the person experiencing it, we have to look closely at the physical mechanism firing inside the brain. The brain does not store experiences as unified, single files. There is no one folder inside your head containing a Tuesday from 10 years ago. This diagram shows a simplified human brain outlining how memories are actually organized. An experience is shattered into pieces. Sights, sounds, and emotions are physically separated and stored across distant neural networks. When you try to remember that specific Tuesday, a structure deep inside your brain called the hippocampus activates. Its job is to search across these scattered networks and link the fragmented pieces back together. As the brain attempts to reconnect those dots, it encounters a problem. If it is missing a piece of data, like who was standing next to you, the brain prioritizes logical coherence over accuracy. It simply generates what makes the most sense and plugs the gap. Psychologists have proved how easily this happens. In a famous experiment, participants studied lists of words like bed, pillow, and dream. Later, many reported seeing the word sleep, even though it was absent from the list. The word fit the pattern perfectly, so the brain supplied it. Your brain operates as a meaning-making engine. It invents missing details to ensure a memory feels whole, blurring the line between actual facts and logical assumptions. The reconstruction process becomes more complex when an event carries high emotional weight. Fear, embarrassment, or sudden surprise introduces a new layer of distortion into the way the brain builds the file. During these intense moments, the emotional centers of the brain take over. Specifically, a structure called the amygdala locks in the emotional significance and the raw intensity of whatever is happening. The amygdala excels at keeping the feeling of an event sharp.
But it frequently fails to preserve the factual details surrounding it. You might retain absolute terror from a car accident while misremembering who arrived first, what they said, or what color the other car was. This biological disparity explains why eyewitness testimony in courtrooms is now heavily scrutinized. A witness can take the stand and recount an event with total conviction, while reporting details shaped by the stress of the moment or suggestions from investigators. Absolute confidence in a memory does not correlate with its objective truth. Someone can sound perfectly certain, feel perfectly certain, and be wrong. This points to the specific moment a memory is rewritten. Every time you remember an event, you pull it into a flexible, vulnerable state. Look at this animation representing a single memory as a completed puzzle. When you recall the event, it triggers a biological phase called reconsolidation. The memory pieces separate, hovering in an unstable and fluid state before the brain files them away again. This is an open window. If a sibling tells you a story during this unstable phase and repeats that you were crying when the event happened, that foreign suggestion slips right into the hovering structure. When the brain resaves the file, it bakes the new detail into the original memory. The brain interprets repetition as familiarity and familiarity as truth. Remembering is an active process of editing. The version of an event you recall today is physically different from the original experience you lived through. If human memory is so easily modified, it raises a question. Why would the brain evolve a system that routinely overwrites its own facts? The brain did not evolve to be a perfect historical archive. Its priority is your survival. To keep you alive, it needs a system that rapidly extracts lessons and predicts future patterns. It prioritizes what is useful over what is precise. We see this system struggle to separate imagination from experience in ordinary moments every day. You might feel certain you locked the front door simply because you mentally rehearsed doing it. Both actions activate the same neural systems. Look at this vintage family Polaroid. If you repeatedly view static images like this, your brain goes to work extracting meaning. Over time, it will construct vivid, personalized memories out of family lore and a simple piece of photographic paper, internalizing details you never consciously experienced. Memory operates as a living draft. It constantly updates its contents to match the lessons, patterns, and expectations your brain believes are most relevant to your identity today. So the next time you feel certain about a vivid memory from your past, you might want to ask yourself, are you recalling the actual event or just the latest version of the story your brain created? And if you find that unsettling, wait until you see how subjective your sense of sight is in our next video.